network engineers make use of VLSM because sometimes we are approached by client organizations that have one network, but in this network, they expect us to subnet into different networks with different host bit requirements, right? You already know IPv4 addresses are almost finishing in the world. So we have to make efficient use of what we have. Hence, VLSM, right? So in this case, I'm going to look at VLSM, the mathematical approach to it, and how we can make efficient use of the IPv4 addresses that we have out there. In this situation, we've been given a network by our client 172.16.8.0 / 21. Is the subnet mask of the network, right? Now, tell me what class is this subnet mask in the comment section. We've been asked to create 3 different subnets for this network, and then in each subnet, we have different host bit requirements. For IoT devices, we have 36 hosts. For DMZ, we have 21 hosts, and for the user, we have 52 hosts, right? So now, like every job, we need tools for this one. And I'm going to employ 2 main tools that I call the binary chart, then the ×2 binary chart. The binary chart is what we already know, 128, 64, 32. Yeah, powers of 2. Then the ×2 binary chart is simply ×2 of what we have on top. I'm going to make good use of these charts and then I'll explain why very soon. First thing that you need to know whenever you're approaching VLSM, always begin from the greatest host bit requirement. Always start with the greatest host bit requirement. Why? Because in VLSM, we're going to do what we call hacking bits and saving bits. When you save the greatest amount of bits that you can save, now you don't have to worry about bits that have been hacked in your next steps, right? But if you mix up the order, you can hack bits that should have been saved earlier. I hope you get it. You will understand more as we solve the example. Then the second thing you have to note for VLSM is you always continue where you left off. So you start from the largest to the smallest and always continue where you left off. Now let's go. Over here, we just said we're going to start from the largest to the smallest. What is our largest host bit requirement? 52 for user. So now let's write that down. User is going to start. Okay. First thing you have to always do is write out our subnet mask. So we have /21, making our subnet mask 111.34567.1234567.8 dot 8 plus 8. We have 16 plus 5. So we have 1, 2, 3, 4, 5. Then 1, 2, 3, right? Dot 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. Now what we're going to do is the user has 52 host bits requirements. Now this number 52, we're going to put it in the ×2 binary chart. Okay, let's look at this ×2 binary chart. Which number can contain 52? What I mean is, which number in this ×2 binary chart is greater than or equal to 52? We see clearly 64 meet this mark, right? Now, putting 52 here, 64 is number 1, 2, 3, 4, 5, 6. Okay, so this is how you go about it. You first check what number can contain the number of host bits requirements in the ×2 binary chart. Then now you count the number of bits. It is the placement. It is so 1, 2, 3, 4, 5, 6, right? That's the sit place. Now you come here, you do what we call, you save the bit. So you come from the right to the left. Right to the left. If you have any questions, feel free to ask. Right to the left. So 1, 2, 3, 4, 5, 6. Now we're going to save these 6 bits. Right? We're going to save these 6 bits if we save these 6 bits, always keep in mind that network bits are brutal. So whenever something is not saved, they hack them. Okay, keep that in your mind. Meaning our network is going to hack the rest of these ones, right? Making our new subnet mask. In this regard, everything else except the 6 saved bits. Okay, so 1, 2, 3, right? Then we go 1, 2. Okay, the network bit has hacked them. Let me write them down. New hack bits. Now, because they are hacked, this is our new subnet mask. Hence, new subnet mask. So, in this user, we save 6 from right to left. Then the rest gets hacked. Great. Leaving our new subnet mask to be / every other thing that we just added, making it / 26. Okay, so this is our new subnet mask. Okay, now how do we find the increment? Because remember, we're creating a subnet, and whenever we're doing subnetting, we're looking at a range, we're looking at the increment. How do we find our increment? We're looking at 52 already. We said this is our new subnet mask. How we find the increment is you go to the last network bit. Okay, the very last network bit. What placement is it? What position is it? In this case, our last network bit is this one, is on the second place, right? Now we go to our binary charts. This is what we use our binary charts for. So you use your times 2 binary chart to check how many bits to save and then how many bits to hack. Then we use our times 2 binary chart to check. We use our times 2 binary chart, pardon me, to check how many bits to hack and how many bits to save. Then we use our binary chart to check our increment, right? Now 64 is our increment. So always start from where you left off. In this case, we're going to start from 0 because that's what we've been giving. Our network we've been giving is, let me start on a fresh place. Great. So now our user network range will be equal to 172.16.8.0. Remember, you always start from the first. Now we're going to increase by 64. Keep in mind, if 0 is already part of the range, then our last number will be 63.63. So I'm just going to copy the same thing and put it here. .63. Pardon. Right? Then, what is our network ID? User network ID is same 172.0. Always keep in mind the network ID usually takes the first host is usually the network, right? So / what did we say was our new subnet mask here? /26. Okay, so /26. Why is it 26? Because we started with 21. We now have how many ones over here? This is 8, 16, 16 plus another third set is 24, 24 plus 2, 26. So this is the approach we use for VLSM. Now we've sorted out for the user. What is our next step? Keep in mind, largest to smallest. After largest to smallest, continue where you left off. So What's the next largest? IoT. Now we're going to repeat the same process for IoT. We're gonna IoT is 36. Okay. Surprisingly, despite the fact that IoT is 36, is still going to be in the same range, right? Because 32 cannot contain 36, so we have to move to 64, right? Now, IoT contains 36 hosts. Okay, start from where you left off. Keep that in mind. The subnet mask is going to be our new subnet mask is what we're working with, not the initial network subnet mask. This is our new subnet mask we're going to be working with. Okay. Now, if we're saying 36, then it means we're going to have to be saving 6 bits. Already 6 bits have been saved over here for us. I'm going to copy the rest. The same thing because it's the same number as our user network. Right. So if this is it, then we already have our new hard bits, and then our new subnet mask is still remains the same, right? But I'm still going to copy it for understanding purposes. My new subnet mask technically remains the same. Let me put that there so that in this situation here, because it does not always remain the same. Right. Then now, after we've taken this for the IoT, we're going to look at our IoT network range like we did for our user. What will be our IoT network range? Our IoT network range will be where we ended. So .64, right? Our increment over here is still going to be 64 because that's when the last network bit is at the position of 64. So 64 to 127, right? Then we're going to take the first host bits for our network, IoT network ID. I suggest you pause the video and then you try your hands on DMZ because it's a little different from what we just did and it's a little challenging. So I suggest you pause it over here and you try your hands on it. Try your hands on DMZ and share your answer with me in the comment section. If you have any questions, feel free to reach out to me, Veronica Saki, on all social media platforms. Cheers.